Okay, they should be on, which is great. It is on. So thank you for all of you who've turned out this morning. I appreciate it. It is an early start, but I just want to thank everyone for being here and start by thanking the organisers of this event, so Oliver and Helen in the front, and hopefully it's going to be a great event. And we're going to be talking about something today which I think is arguably the most significant achievement of the 20th century, and that is, of course, humans leaving Earth, and not even leaving Earth, but actually setting foot on another world, on the surface of the moon. And that's what we achieved 50 years ago this month. And it's hard to believe that photo on the wall up there is 50 years old. That's Buzz Aldrin with one of the solar experiments. And I was told kindly last night, and I have to credit Alan Boyle for this, who organised this panel, that the solar experiment is a Swiss experiment, and it's fair to say that technically the first flag on the moon was indeed a Swiss flag. Take that, what you will, to any Americans in the audience, but it just goes to show that space exploration is truly international. It's about you and I and everyone, and it's the cliche that astronauts always say that from space there are no borders. But as we look forward to the next 50 years and a future in space that we probably can't even imagine, just like we couldn't imagine the future we live in right now, where will we be in terms of space exploration by 2069? We don't know, but hopefully our panelists, which are made up of an international team, will hopefully be able to give us some sort of answers. Is this about commercial space? Is this about public-private partnerships? Forward to the moon, to Mars, perhaps even manufacturing and data in space. There are so many exciting things happening. So it gives me great pleasure to introduce our first panelist, David Parker from the European Space Agency.
Thank you very much. Good morning, everyone. So it's a pleasure to be here. It's a strange thing to be looking back 50 years and looking forward 50 years at the same time. In just 18 days' time, European Space Agency astronaut Luca Parmitano will be getting aboard a Soyuz capsule on the 20th of July to start his journey to the International Space Station, on the picture on the wall here. The third European commander of the space station, but a symbol of the transition from the space race to international cooperation in space exploration. I want to take you on a bit of a journey to say a little bit about the future of space exploration, maybe the next 10 or 20 years, and then we can talk maybe in the question and answer session about the 50 years into the future. But we're definitely entering a new era of space exploration, because announcements are being made almost every day. I've got something to say myself in a few minutes. This is a critical year for us in Europe because our ministers meet in Seville at the end of this year to make decisions about the future. And uniquely, I think, among space activities, space exploration is this combination of curiosity and opportunity. The curiosity to venture out into the unknown, the opportunity to come back with new visions, new understandings through exploring with humans and robots. In Europe, our space exploration vision is based on 3 destinations: low Earth orbit, Moon and Mars. Low Earth orbit is where we live and work aboard the space station. The Moon, I think, has become even more interesting since the days of Apollo because of the discoveries we made since the days of Apollo. And Mars is a fascinating destination because of its potential to tell us something about the presence of life in the universe. So, but while exploration without science is just tourism, exploration is also technology, it's innovation, it's new technologies in energy, life support systems and so on. So it's an important source of innovation as well. A kind of simple example, you and I use 100 litres of water every day. On the space station, we're down to 5 litres of water with recycling. But to go further, we have to do a lot better. So how does the moon fit in? It's kind of the Earth's 8th continent, awaiting our return for the past, since 1972, a museum of 4.5 billion years of solar system history. So we haven't really explored it properly. Certainly our robotic explorers will go first, for example, in search of water. So there are missions that several space agencies are looking at to see whether the water that we now believe is there. How will humans go there with Orion? So Orion is NASA's deep space spacecraft, and on the European side, we're contributing the power and propulsion to support the astronauts on the journey. Where will they go to? Our kind of deep space spaceport, the Lunar Gateway, which is our base camp for exploring the moon, but not just going back to the moon, in my view, going forward, which means doing it in a sustainable way, a way to stay there, not just for a few days, but for weeks and months at a time. So Gateway will be 1,000 times further out in deep space than the space station is today. And, but we don't want to leave it there. We also want to go on to Mars. We're already at Mars with a partnership with robots and space agencies around the world doing that already. It's certainly the horizon goal for human exploration. And so as we go beyond the robotic missions today, one of the things that Thomas and I are talking about is undertaking a round trip to Mars, a Mars sample return mission. This could be a next big step, as a step towards the human exploration, which maybe comes a little bit later, the horizon goal, let's say the 2030s, 2040 maybe. But all of these steps are preparing for this human landing, and whether all of this happens depends on political decisions as much as technical decisions, and for us it depends on the conference at the end of this year. But we're preparing for success. So I'm very excited to make a bit of an announcement. Last week, our 22 member states gave us authority to ask European industry to make costed proposals for European contributions to both the Lunar Gateway and to Mars sample return, beginning with the International Habitation Module for the Gateway and the Earth return orbiter for Mars sample return. Again, this is all dependent on, actually happening dependent on decisions by our ministers at the end of this year, and you can read a lot more about it by going to this blog. So I think in the interest of time, I'll leave it there. Thank you.
Thank you very much. Can we have a round of applause for David, please? It is early, everyone. I just want to pick up on one point from what you're saying, and it's something we'll discuss later as well before we move on to Thomas, and that's, we talk about forward to the moon, and that relevance of, it's not about redoing something we did again, it's not about flags and footprints, but it's about sustainability, as you mentioned. So how is this new era in exploration going to be different to what we saw with Apollo?
Well, the way I like to talk about our first expeditions to the moon is a bit like the race to Antarctica around 1910, 1912. And then after that, we kind of forgot about the Antarctic regions. Then we went and built research bases, and people are living and working at the South Pole now, doing all sorts of science, discovering the hole in the ozone layer, even looking for meteorites from Mars. So this time it's about living and working there, not exploring the museum properly. I always say the moon is a museum of 4.5 billion years of solar system history. But last time we just went to the museum gift shop, grabbed a few souvenirs and came home again. So we need to use the robots and the humans working together. We need eventually to explore a large area and maybe build a lunar base.
Just very quickly, because I have to ask this before we move on. When you mention the historical examples, throughout history, exploration's been a one-way trip, with the exception of being space. Will this change with space exploration?
I think the round trip is the thing about exploration. I sometimes use a picture of voyages made. My home city is Bristol in the UK. John Cabot or Giovanni Cabotti was an explorer, and have a lovely image of the elliptical missions he made across the Atlantic and back again. And so exploration is really about coming back.
Okay, fantastic. So moving on to you, Thomas, I won't embarrass you by pronouncing your second name, so if you could do that for me. And Thomas is from NASA.
Yeah, I'm Thomas. And I'm not ESA.
Next slide. Go forward 2 slides. It's the next presentation.
We're just trying it out, see.
We're just waiting on some.
I shall go without presentations, but let me just tell you, without slides, that is. But what I want to do is, of course, tell you that what David just talked to you about is a plan that we're working on together. So I'm not going to tell you again what the plan is, but I want to focus on 3 elements of that plan that are really critical. And here's my last name if you're interested. But the first one is actually that picture. I was really excited, and of course, to be part of an international celebration with Jan Werner, myself, other officials in Bern, really celebrating that experiment. You talked about the international character, even then with Apollo, with that experiment. It's the only international experiment that was there, an experiment that provided data about the sun that in its accuracy was only surpassed in the late 90s, early 2000s. So yes, you can do amazing science in conjunction with human exploration. Yes, it was put up before the flag, and I think it tells us about the integrity of the Apollo program, not about any other priority. By setting it up, the exposure, which is the key characteristics of that, the exposure time, was increased by 17 minutes. If it was done in reverse, it would have been less. So yes, the US flag was the most important part because of the geopolitical situation, but 15 minutes later for the US flag had no difference. 50 minutes later for this one did. Therefore, because of the integrity of the program, it was done the right way, which is like this. Yes, international collaboration is exactly what we stand for as we go in the next decades into deep space. We want to do that together. We want to do that together as a community, an international community. Of course, that bring our international aspirations to bear, but do so in a way that we're not all the same, but we all bring the diversity of opinions to bear that will go forward. We're going in steps. One of the key steps that we're using we just made an announcement yesterday, is that we're actually doing that with commercial partners. The creative way is the fastest way, we believe, to go to the surface of the moon with instruments, later on with astronauts, of course, and this one actually is one that's going to be held by astronauts, but now robotically is by not starting over to build landers. There's companies out there that say that they can build landers. They have customers, and we're starting to invest in instrumentation that allow us to do science that's urgent, science that's been out there, that's novel, science that's high class, and we can use the opportunities provided by the international community through that going to the moon and then beyond, using this to actually do science that otherwise we could not get to. This is done by a company. This next one is done by a university that develops an instrument that in this case measures the heat flow on the interior of the moon, very much similar to some of the elements of the InSight mission currently doing at Mars. Human and robotic exploration will be together as we go forward. National programs, international communities, and commercial activities will go together as we go forward. That is the difference. We're not doing it in vacuum. We're doing it together. We're moving it forward, and that will create, if we're doing it right, sustainability. Because the strength of the Apollo program was its speed. The strength of the Apollo program was its tremendous impact overall. The weakness of the Apollo program was its lack of sustainability. Once the footprints and flags were there, we were heading down the hill in terms of the enthusiasm curve, because we did not have the elements there. It was a success of its time. There's no desire to do that again, no matter where we want to go. But I want to also tell you, yes, we want to go to Mars. You've already talked about that, but I want to just tell you something we announced yesterday. We want to also go, last week, we want to go to other places. Here's another moon we're going to go to. We're going to launch in 26 with a mission called Dragonfly. It's a mission that has controlled flight. It's a drone that will fly in the atmosphere of Titan that has 4 times the pressure at the bottom than the Earth. And therefore we can use this vehicle, which is I call it Santa's sleigh, but again, it's Dragonfly, that is taking measurements and actually travel on the surface of Titan of the order 150 kilometers, doing research in this world that besides its history and besides its scientific excellence, which an interest that we've learned by our international Cassini-Huygens mission, has elements that we want to explore, which we believe could be of interest in the quest for finding life elsewhere. So as we go from the moon to Mars in this international and commercial community, we stretch beyond that. We stretch beyond that with technologies. We stretch beyond that with our aspiration and our science questions. Because some of the simplest questions in our minds since thousands of years, we yet have to answer with the tool of science. And this is one of those attempts. Thank you.
Great, and a round of applause for Thomas. And I think there's so many fascinating points there, and we'll touch on the life elsewhere when we get onto the actual main questioning. And by the way, if anyone in the audience wants to ask questions, there will actually be microphones down the end of the stairs for people to ask questions to. But just picking up on some of your other points in terms of science, because when we reflect on Apollo, as we are doing now in this 50th anniversary month, we think so much about the human achievements, but in terms of scientific exploration, how much have we achieved in the last 50 years? Because often so many people are frustrated that we haven't been back with humans, but robots really are leading the way.
And this is really one of the most transformative issues. And of course, Laurie's going to talk about that, and we're really of one mind on this. And that is that by going away from the Earth, we've discovered the Earth in a way that we've never seen before. This morning, the weather forecast was here. 70% of the value of that forecast came from space. A third of those came from spacecraft that NASA built. Close to a third from spacecraft that ESA built. JAXA and others are the other third. It's an international community that helped us understand our planet as a whole. But beyond that, we've explored these other worlds, that keep you up at night. They're mind-boggling. Things like Europa and Enceladus, spurting organics into deep space. We've flown by Pluto. We've seen a Kuiper Belt object, the Europeans with their Rosetta mission. How exciting, to really get to know nature. Nature is way more beautiful, more wonderful, that because of Apollo, because of the fact that we have these technologies, and it made us better. It helped us understand that we're on a planet that has a certain fragility to it, a planet that we're affecting ourselves, and a planet that we want to take care of.
And would you say that, you mentioned some of the great missions, including the European Rosetta one there, but would you say that sometimes what we're discovering in space is almost beyond the imagination? It's incomprehensible, some of these discoveries that we've made?
Oh, it's whenever we look at nature really, really carefully, it blows our minds, no matter where it is. And the space is no exception, perhaps. It's the quintessential frontier of that. I mean, look at the exoplanets, right? I mean, I finished my PhD in '96 here in Switzerland. 95 was the first announcement of 2 exoplanets that's discovered down the street here in Geneva, and look where we are today. We know, I look in the sky right now, I know that for every star I look at, there's a planet. Yeah, I can't see it, but we know it's there, and many of these planets, a much larger fraction than we would have ever guessed, are at least geometrically in a habitable zone, which is of course only the first gate you go to many, 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 many more questions to be asked, including about atmospheres. But yes, it blows our minds, and that's what nature does when we explore it. That's why it's so exciting.
And this is why again, 20, 30 years ago when I was studying, astronomy was out there, and then there was planetary science. But actually, it's now, planetary science is about our backyard to try and understand all of those exoplanets out there. So there really is, it's a continuous voyage of exploration in our minds as well as with our spacecraft.
I agree, and I think the future in terms of science really is something that we can't imagine. But moving on, Toshi, to bring in the Chinese perspective, because it's fair to say that 50 years ago, China wasn't involved in the space race, but exponentially over the last decade, perhaps 2 decades, China's made huge successes, particularly in terms of robotic exploration. So I'm interested to hear what you have to say.
Okay. My name is Jiwu from Chinese Academy of Sciences, and I'm very happy to be invited to this journalist conference. The first time for me to participate in such kind of conference. Particularly with the topic of 50 years anniversary of Apollo landing on the moon. So I bring a few photos here. As you mentioned, we have been involved into space technology only from the early 70s. So by the time when Apollo landed on the moon, we have no ability to launch satellite. And but when I was young during that time, I still remember this event, this great event for the human beings. And since then, we have developed our own space technology, and only until very recently, 2004, we have our lunar program. And the first orbiter was launched in 2007, And then we have Chang'e. It is called Chang'e. Chang'e is a goddess of in the Chinese fairy tale, and she goes to the moon. So we want to follow her. So Chang'e 4 was the fourth mission we set to the moon, and then it was a copy, actually, it's a backup copy of Chang'e 3 with the rover, lander, and rover. So when the Chang'e 3 was succeed, we decided to go to other places to use this backup model. So we decided to land on the far side. And this is really difficult. I will mention that with the help of a relay satellite. And then with the relay satellite, we decided to land on the von Karman crater. It was a great US scientist named with his name. And we have, there was the father of Chinese space industry, Mr. Qian Xuesen, was a student of von Karman. So probably that's one of the reasons we land there. And it is a small crater, and but with a quite flat area inside. So the lander was precisely land on that place, that's a little yellow cross there, and with the same technology of Chang'e 3, landing and a rover drives out. So the rover is called Yuzhu 2, Jet Rapid 2. So until now, this rover is still working very well, and after a few months, it's pity we have to go to sleep during the lunar night. So we hope the US technology can send a nuclear power station there, and then people can work during the lunar night. We waste half of the time, more than half of the time, because of the lunar night. And now you see the red track is where the rover has been going, and then there are a few places has been interested. And with the instrument of it's called far infrared spectrometer, we have discovered the surface material are slightly different from the near side. So we measured the very original mantle of Earth, which is jumped out from another place. If you compare with the figure we measured on the near side, it's quite different. So it reflects the early age of the lunar development. It is still there, so which means the moon doesn't develop so much. On the far side you can see it, on the near side you don't really see it. So this was quite interesting discovery, and was recently published on Science. And this is the figure, detailed analysis, which is the mantle was jammed from another crater nearby. So all this has been studied. But with why we can land on the far side, it is not difficult for technology. The only thing is we need help of a relay satellite. And this relay satellite was launched half year before Chang'e 4, and flying at Earth-Moon system L2 point. And there you can look at the Earth, both the Earth and the Moon, all the time. So the signal was transmitted via the Earth, via this relay satellite, and down to the rover, and the measurement result transmitted to the relay satellite and down to the Earth. So with the help of the relay satellite, we can really do the landing on the far side. And this relay satellite is still there. It can help other countries to land on the far side, use the same relay satellite. So there's no problem for China to collaborate with other countries, and we welcome other nations to use this relay satellite to help their landing on the far side. Thank you very much.
Thank you, and a round of applause for Jesus. The Chang'e 4 mission was a huge success, not just for China, but for the world. And I think most of us within the space industry, or even those from the outside, are aware that China's got huge ambitions in terms of space exploration, both robotic and human. And one of my questions is, and I want to get onto collaboration after we've spoken to all the panelists, but in terms of human exploration, is China planning to send humans to the moon?
Yes, it has been, we have been talking about that for quite a long time. it's very political. The general public wants that. And if we want to do that, it's really for the general public. And for human beings, it is not the first time. But for Chinese, this is a very significant step. But at the moment, we are building our own Chinese space station, as you all know. It's near-Earth station with the 3 modulars. And this is still ongoing. So that takes a lot of effort from us. And this is also human activities. And this station will be finished, the construction will be finished by 2022 and last for 10 years, up to 32. So during this period, we have a lot of activity to use the station. So if we add lunar landing on the moon, it's not impossible, but it's something in parallel with that. So it's the natural strategy how to do that. There's no decision yet.
So within the next century, do you think, perhaps next decade even, do you think Chinese people could be first on the moon? Perhaps the first woman on the moon could be Chinese?
No, the first woman will be US.
Okay, so America will get to the moon before.
They have the plan, yeah.
And just one quick point, because it was an important point you mentioned at the start of that, and you talked about your own inspiration from Apollo, and I think that's one thing we can galvanise moving forward in space exploration as well, that it doesn't matter what nation you're from, that when we see these great achievements in space exploration, we're going for all of humankind and not just for one nation. Do you agree with that?
Yes, I agree, yes.
Okay, great, and thank you very much. Now moving on to Anatoli. Please tell me I pronounced your name correct. that face was like... it would be great to get a Russian perspective in terms of where we are now and where we're heading, particularly with the scientific missions as well.
Okay, thank you. I'm Anatoli Petrukovich from Russian Academy of Science, and actually my colleagues have already made a lot of points which are, of course, I agree with. I would just attract your attention to several aspects. This is the concept of Soviet lunar base taken in roughly 1970, and it was actually partially in metal, so like photo in the left corner. And the idea of this lunar base is that human settlement is in the center of it. And while there is not so many robotics spacecraft around, but if we look on in the modern concept of lunar base from Russian industry, then it is total change of concept. The robotic stations are in the center of attention, and the humans are just assisting robots to do something which is at some level not accessible by robots. And I think this is a very critical point when we are thinking about future 50 years. Space industry is actually a very conservative one. For example, currently humans are flying to space on a rocket which was essentially designed 60 years ago. And the launching site is still the same, which is 60 years old, and it is quite alive and it will work for several tens of years. That's why successful technologies are working for tens of years, maybe for 50 years, and we should be very smart to catch the proper trend now. What we design now, at the best, should work for 50 years. When we're speaking about super heavy rockets, about human presence on the moon, we should think how it will look like in 50 years. And in this sense, I think that the most critical, the main goal of the human in outer space is to reach, to increase level of autonomy of humans in space. It doesn't mean, it need not to be necessary to be done specifically on the moon. The moon is the most convenient place for this. But if we want to go forward, we need first of all to learn how for humans to live in space on their own, without every minute help from Earth, like it happens now, with control centers controlling every second of human crew on the top. And that's why when we're speaking specifically about science on the moon, when we add the human to the science, it increases the price 10 times, roughly. So I think that the future of this science program of the moon is mainly robotic. And We, again, the final thing which I want to say is that when we were looking on the lunar program, on the space program 50 years ago, it was on the top of the human technology. Actually, the space industry created new technologies which were spread back to the other industries. Now, situation in many aspects is opposite. There are a lot of ground Earth technologies which can be successfully applied on Moon. For example, currently we have a lot of robotic means which can transport everything, load, construct, assemble something, disassemble, pick up samples, make reconnaissance of the surface around. We don't need to invent other artificial intelligence for this. So all what we need is just to adapt these systems to space environment. And this is, I think, again with this conservatism of the space industry, where if we make a wrong step now, space robots will be lagging behind Earth robots in 10 years. I'm sure in 10 years everybody will have some artificial intelligence in the pocket or some robot nearby, but we should be planned correctly so this technology is fully applied on the Moon. Thank you.
I think you make a great point in terms of robotics and also technology, and I think it's a term that's used in Europe a lot, and it's a spin in, spin out, which is a terminology. So it's a European thing. But in terms of the technology that we're seeing developed here on Earth, what is the potential that it has to disrupt future robotic missions in terms of lighter weight materials, stronger weight materials? Is it almost like a limitless end to the possibilities to come with new disruption in robotics?
I mean, in space?
Yes.
In space robotics, I think energy sources is the critical thing. We need to be, if we're speaking specifically on the Moon, we need to survive somewhere, somehow during nighttime easily, or maybe even operate during nighttime. This is the first candidate for this is, of course, nuclear sources, and the second point is then we need to think about batteries, space-graded batteries, which should be resilient enough and to keep enough energy to work on the to accumulate enough energy for 2 weeks, for example, of operation. And the second issue is, I think, application of artificial intelligence. We have a lot of, maybe we need somehow to reduce our acceptance of risks in space. In space it's very conservative in terms of risks, but we have a lot of robot technologies on the ground and people really experiment every day. And we need to move this spirit of investigation and tests from the ground to Moon, so that robots on the Moon should live their own life and upgrade very fastly. And so people should have the right to make some error with robots. With humans, we cannot afford making a mistake. In this sense, with robots, I think we need a little bit more aggressive, be more aggressive in permitting people to experiment on them.
And just very quickly before we come on to Laurie, you mentioned risk, and do you think the onset of this new commercial space race where private companies are able to take risks that governments can't, do you think that's going to change things in terms of robotics?
Yes, it should change significantly.
Okay, and last but by no means least, Lori Garver, who CEO of the Earthrise Alliance and also former Deputy Administrator of NASA.
Thank you. Well, it's wonderful to be here. I speak to you, so the panel, sorry. The reason I think I have been added as the only non-government employee here, we're supposed to talk about predictions, and instead of being a space scientist, I am a political scientist. And we went to the moon 50 years ago, what we're celebrating, for geopolitical reasons. That's been addressed. It's fascinating to me to see how in 50 years the rest of the world sees that mission and confidently believes the US will be the next to land humans on the moon, which I think certainly a chance as well. But I think these comments about the reasons we go have more to do with what will happen next than any sort of past reason. So we went to the moon to beat the Soviets. We went in the Cold War. And 5 US presidents have in fact stated we're going to go to some far destination, either back to the moon or to Mars within a certain time frame. President Trump currently saying we will be doing that in 5 years with a woman. We have said this before, we have not gone back, and I think the reasons are because when we went, it was in a race and we won the race. So when we go back, what is the goal? What should we be doing? Why do we go to space? We have a space agency in the US because of the International Geophysical Year. We were a science-focused agency in the beginning until we had Sputnik and we had Yuri Gagarin, and that incentivized to do human spaceflight. So in the United States, we've been trying to live up to Apollo and human spaceflight for the last 45 years. And I think most people feel we've fallen short because we haven't landed on the moon. But in fact, humans have been living and working in space for nearly 20 years now. And we do that in a way that is international, which geopolitically you have to acknowledge is a much better way to go about something like space exploration than going on our own. We can say lots of nice things about the Swiss flag being first, but that is not the way the United States saw it in 1969, to be sure. So the value of the space program, the space activities, have to justify the expense. And human spaceflight is order of magnitude more expensive than robotics. A lot of the exciting things the panelists talked about today are robotic and will be done and can be done, and I think technology, as Anatoli stated, will really drive what we're able to do. If we can land a helicopter on moon, is it Titan? It's going to Titan. We have been talking about that. I was at NASA in the 90s. I was Deputy Administrator of NASA during the Obama administration, and we have been trying to do these things, but the technologies weren't there. So as those develop, and we don't know what it will be in 50 years, there's going to be very exciting things. But why do we spend the money for humans is a different challenge. Because if we aren't going as a race, are we going to cooperate? Do we need humans for the science? Or are they just going to tend the robots? These are all questions, and I believe that the commercial space value that we give is to lower the cost so that the bar isn't so high. So we don't have to spend what we did in Apollo, which was 4% of the US budget, and now that we have reduced the launch cost, space transportation used to be the most expensive aspect of anything we did in space. So as we reduce that, as we get competition to go back to the moon, and as markets are open, I think these things will happen without necessarily full government, maybe government leadership, but maybe not all the money. And in fact, that the costs will be greatly reduced if we have additional reasons to go. But as I look at the value of space and what we really benefited from this photo, from looking back at Earth from space, we can tell that we are having an impact on the planet. This is the Amazonian rainforest, over 33 years of satellites looking at the disappearing rainforest in the Amazon. The yellow outline pieces here are the indigenous protected lands in the Amazon, and they are literally all that is going to be left in a few years. We have also seen just over the last 2 years, this is a glacier in the Yukon, where as it melted, it is now just in the last year feeding a different lake. Instead of flowing south, it's flowing north. And so a whole community, a whole lake is going away, disappearing. And they are finding in the Alps, this is happening as well. As glaciers melt, it's going to change the topography. It's going to change people's lives. It is changing people's lives. And to me, I think the value of space largely was that we went to beat the Soviets, and we look back and we found we're all in one fragile planet together, and we are going to use that to the benefit of all, I hope, over the next 50 years. And if we don't, we're not going to be doing any of these things.
Thank you very much, Laurie. I think, obviously with the name of your company being Earthrise as well, I don't know whether we can get that initial slide back up again. Potentially not, but the greatest thing to come from Apollo, the science was great, the inspiration was great, the competition, but it was that image. It was Earthrise, and it was being able to look back and to see us. And in your opinion, how much value in terms of space exploration has come from being able to get that bigger picture, that perspective shift of Earth?
Well, of course, there's a scientific benefit that Thomas mentioned as well, that we get from space and have gotten since the beginning. I think that perspective from the moon, it was an accident. The guys who took that photo on Apollo 8 love to argue about how it happened and who ultimately took the shot. It was Bill Anders, but they found it overwhelming to see the Earth from that distance behind the moon. And since that time, the amount of data we have received about Earth has literally changed what we know. We have discovered many things that hopefully I think most people in the world now recognize we need to do something about. But the perspective that every astronaut, there's now just over 600 people, have gone to space, only 18 to the moon, but of those 600 people, no matter what nationality, they have an overwhelming different perspective when they return. They talk about it as the overview effect. We used to talk about trying to have peace talks on the International Space Station, having it be the potential for a Nobel Prize, because you cannot look at the Earth from space and not get a sense of your humanity for your fellow humans and for the fragility of the environment.
And do you, there's so many points to pick up on that, but do you think that moving forward in the next 50 years, as you touched on in your presentation, is going to be about utilising space technology and the data available from space to look after Spaceship Earth, to help us realise we're all in this together?
I hope so, and we don't have 50 years. So I think that we really need to, when the U.S. is got capabilities beyond just the government, but things the government invested in, that the private sector is doing. Somewhat the military is driving the technology, but utilizing it for humanitarian purposes to better be able to model the climate, make predictions for adaptation and mitigation, and ultimately to establish some, in the United States at least, common understanding that will underpin policy changes that are necessary to literally make sure humanity can survive here. I don't think that's all that we'll be doing in 50 years in space, but I do think probably in the US, a president after the current administration, whether that is a year or 5 years, is very likely to utilize that aspect of space more than we are utilizing it now.
Do you mind if I,
Yeah,
I want to actually, I really ask a question though, because needless to say, very much second the thoughts that are out there. The one thing that I also though want to point out, just want to run this off too, is like, there's many aspects of Earth we're still discovering. So yeah, so there's many things that are there that we're looking at, but there's many aspects of Earth that context, kind of connections between various systems that are making this planet what it is, right? That we're discovering today, right? Kind of elements that are there. And so for me, the one element that I believe we should use the data and the right people in the right places at the political places. We should use the data, make it all available openly. All the entire community of spacefaring nations should put the data out there because we're a better world because of it. But we should also not stop discovering what is there, because in the long run, the solution space that we have, it really depends on actually understanding at the deep level how these systems react to that.
Yeah.
Well, I do think that is a uniquely government role that I do hope NASA and other agencies continue to lead, because the private sector is not going to do that. They're taking this technology, utilizing it, developing new markets, and for humanitarian reasons. But it's not just in the sensor technology that you drive, but it's also modeling. It's the most complex thing we've ever studied, and we don't know everything.
And it's been a strong thing in Europe to make the data available. So with Copernicus, we now have the world's most advanced 24 hours a day monitoring of the Earth, and all of that data, terabytes of data every day, is freely available, and it's vital that that.
And moving forward, because obviously we started late, so we're going to have to try and get through these questions as quickly as possible. Just, we touched on this in terms of governments, but really, from my perspective, where I work half within the commercial space sector, it's as much about private industry and business as well. I think this is open to all of you. Do you see the way that government space agencies currently are shifting? Do you see them more becoming, within the next 50 years, almost like an umbrella organisation to enable science, and then you've got private industry coming forward and taking those risks?
Well, I think one of the challenges is to understand what you mean by the word commercial. Because there are two different meanings, one of which is there's a private customer paying for something that they want privately from a private space company, or there's a space company being paid by the government to do something. Within ESA, that's what we've always done. All of our money minus the management cost is going to the private sector. We place firm fixed price contracts to buy things. But increasingly we'll go into buying services. We already buy launch services. Now we're looking at buying a ticket to the moon, buying lunar transfer services, communication services for lunar exploration. And then that mode of operation is already happening. The question is there any money to be made by going to the moon? And that would be a really commercial activity. And so far, nobody's spotted the way you make money by going to the moon. And therefore, that's why the government is going to continue to be the driver, the initiator of the goals of exploration, in my view.
Of course, we're not just looking at the moon, we're looking at space, we're looking at utilising data. Investors in the commercial space sector at the moment, by commercial, I think you're correct. We have had contractors, private companies working for governments, during the space race, but we're seeing a shift. We are seeing more companies. We're seeing people who leave college and they want to go and set up an idea and disrupt the system instead of going to work for ESA or NASA or the Airbuses. But in terms of investment in the future, and I think the Chinese model is quite a good one to look at, are we going to see perhaps organisations such as NASA taking a back seat? We're seeing more commercial private organisations which take those real risks.
We have the same situation, similar as all other countries. In the commercial space area, there are two kinds of companies. One is with private enterprises, but taking job from the government project. So those companies, they work more efficiently and they have lower quotation, so the government would like to use them to balance the spendings. Because some of the state-owned big companies, the money goes up, the price is always going up because the company become bigger and bigger. So that is the issue for everybody. Another kind of private company is more on innovation, and they want to open their own market, and the business is more coming from the general public. And those parts of companies, I rather call them new space. The other part is still within the old space. When the money investment coming from the government, it's always for political reasons or science, because no private company would like to pay for exploration. So this is the government duty. But if general public can generate a new market, a part of this, outside of this, then it's a new space. I'm more interested in looking at that part. So if that part grows, it will change the entire scenario of space business.
So will our agency change as a result of that? It's better. And the simple reason for that is, and already now, the simple reason for that is, if it's not, we're not doing getting the best value per dollar, or whatever currency we all have up here, the best value per dollar from it. And so What it means, though, are two things, and they're kind of contradicting to each other. So the first thing it means is that as government, we go forward and basically understand what the players are out there. Now, that space, that entrepreneurial space, has very different rules than the contractor space that is there. Like, for example, the first rule of it is the rule of reality aberration, the reality distortion at the beginning. If I'm doing a pitch to a venture capital fund, the first task is to explain a future that I have no clue I'm getting to, how I'm actually getting to fully, but I basically say I have enough information to start moving. That's what's called pre-seed or seed capital. That's what you get from that. Now, the problem I have within the government, we don't have a lot of people that understand that. Like, don't believe everything they say. That's not the rule. They don't believe that that needs to happen. But the thing is, we need to start, just like a pre-seed and a seed fund, start using these services. So we, at Science itself, we're running 5 experiments right now, and we call them the experiments, just because I don't want to use the word seed fund within the government, but we're buying commercial services to the moon. You know, let's see out there. If they can't become commercial, well, we'll stop. We're buying data from Earth observing companies and so forth. So that's that. Well, the downside of it, I just want to talk about the human side of it that we're struggling with too, is that one morning, one NASA employee comes to work and somebody says, you're done. What you have done now, you need to stop building, you're now supporting this other thing. And that transition, you know, even though kind of at my level, it's kind of obvious to say those things, but that transition is really a transition that needs to be done with empathy and done the right way. But yes, we need to do it, and yes, we are.
Okay, great. We're going to have to move forward, and I'm going to open it up to a couple of audience questions, if anyone has got them, if they're able to raise their hands. And I'm told there's microphones in the audience. There's a lady down there at the front. There should be a microphone just to your...
Yes, just go to the microphone. And while you're doing that, maybe just a quick read on where we're going to be in. I'm Alan Boyle, I'm the organizer, and a quick read on where we're going to be in 2069. How many people are going to be living on the moon, if you just want to kind of...
yeah, we're going to get to that after questions, but great.
We have about 2 minutes left.
Do you want to answer your question?
Sorry. So you are all mentioning that there was a geopolitical motivation 50 years ago, and now you're all talking about international cooperation. So you wouldn't say that we are living a new space race now?
Can you repeat that question?
I got it.
No is the answer.
You don't think we are? I'm interested in what you guys think.
Not a race.
Not a race. Is it a race?
It's not a race, but you see, political figures are like kids in the kindergarten. They behave with the crowd. Either nobody goes, either nobody wants something to eat, or everybody wants.
If they want it, you want it.
So yes, so in this sense, it is a kind of a race. So, but in this race, everybody is helping the neighbor.
But you can decide yourself whether you participate or not.
Okay, well, great. Thank you very much for your question. Any more questions before the lady there? That'll be our last question before you move on to...
Thank you for the panel. I am Dr. Saray from Gazi University, Ankara, Turkey. I make communication research on science journalism. My question is, which language will you speak on the moon? Is there any agreement on another international language? Thank you.
So what I'm really looking forward to is this chip that I can put in my ear, and you speak Chinese, and I hear it English, and I speak English as the same chip in your ear, and you hear it Chinese, and it's in.
You have it now.
Well, we have it, but it's not. I want it in my ear, so I don't have to, you know. And it's not slow. The computational capability are not there. But I actually think to get to that is a decade, perhaps. I mean, I just really. So I think language, kind of the type, kind of understanding and language are not the same. Much better. You know that much better than I do. You know, kind of, and the cultural issues are still the cultural issues. Even if I know Uji for quite a while, we've worked together before I went to the agency and so forth, we were in the same place. I think I understand them pretty well, but we still have different cultural context, so that we have to learn. But the language, I just don't think on a time scale of 50 years is a problem at all. I just really think it's over, and the technology will take care of it.
What you're talking about is the famous Babel fish of Douglas Adams, but you're hinting at the technology that we haven't talked about, which will make the difference, which is transhumanism, which is the integration of humans and technology, which is starting to happen. And in 50 years, I think this will have a very important role to play in space exploration.
Okay, great. And we're going to wrap up now with the final question, which, to quote Gene Cernan, who's still, the last person to walk on the moon, and who passed away still being the last man to walk on the moon. 50 years ago we were walking on the moon. Today it's lost in history for the most part, but instead now we have this space future we couldn't imagine. We've learned to live and work in space, and we've landed on comets, and we've done all these incredible things. Where do you foresee us being within the next 50 years, and what do you think we can't imagine that might happen in the next 50 years?
You're asking us to imagine the things we can't imagine.
Yes. And I'll start with Laurie.
Well, I imagine that we will have solved our Earth-based problems partly through our knowledge that we've gained from the perspective of space. I think the Antarctic example for the moon is a good one. I recognize that the governments still spend the infrastructure costs to support those bases, but there are private researchers, there are tourists, there are all kinds of wonderful things we're doing in Antarctica. I would love for that model to be Mars rather than the moon, and the moon be commercially developed with more people who at least visit for purposes of tourism, and I think 50 years we ought to be at that point.
Anatoli, where do you think we're going?
I would agree that definitely in 50 years there will be more tourists on the moon than anybody else. As for some commercial services like resources, I still doubt. We don't know how fast we will move in the next 50 years. Maybe we will find something which will on Earth, in space, and the moon will just look like a resort as a backyard for grilling meat, some meat or whatever else.
Yes, if we look 50 years from now, I don't believe the government money will spend on the manned mission, permanent manned mission, because it's useless for political reasons. Or for science, you go there and you do something and you come back. But only if the new space growing up and there's enough money coming in, and then the space tourism can be a sustainable mission for the human beings to stay on the moon. But people will go there for spend holidays and coming back. But staffs of the hotel will work there. So there will be permanent human habitabilities there on the moon in 50 years.
Robotic stuff.
No, not necessary. Not necessary.
Yeah, I mean, actually, kind of agree with the overall theme. I think the one element we haven't talked about is that we're going to look beyond that. I think on the timescale of 50 years, the question is where are habitable planets elsewhere? And it's not because we want to escape the Earth. The Earth is a wonderful place that our duty is, I'm a father, duty to my children is to leave it the best planet we can leave it, with the best knowledge and with the best action. But it is human strive to go elsewhere. I think on the timescale of 50 years, we will know whether there's places out there that may either harbor life or the ability, the environment for us to visit. 50 years is a long time. We should dream that.
Well, here's an idea. 50 years' time, we'll be abseiling into the ice crevasses of Enceladus in search for life. But whether that is being done by a robot, a human, or a cyborg, I don't know.
Great, and I will end it on that unique thing, which I'm sure you can imagine. I think you'll all agree that space enables humans to dream the impossible and to go out and just do things we never thought we could achieve. And I think our future in space is one that will be positive, not just in terms of exploration, but also bringing real benefit here to Earth, because we go into space not just for that investigation, that curiosity, but to look after Earth. And I think as we look forward to space exploration, particularly in terms of what you were saying, Laurie, the real benefits will come from looking back and improving life for all of us on Earth, because we are all in it together. And I would love a huge round of applause now for our fantastic panelists, and thank you very much.